Okay, today we're going to talk about sequences. So this should be a review from both what you did in secondary 1, but I also think you touched on it in secondary 3. So a formula that is defined each new term by one or more of its previous terms is called a recursive formula. Whereas a formula that describes how to state any term in the equation we call it an explicit, or sometimes they'll refer to it as a standard formula as well. And then we have a sequence is a function f of n with a domain of all the natural numbers or a subset of consecutive natural numbers. So natural numbers meaning, hey, 1, 2, 3, etc. The script notation a sub n is often used for a function and it represents the nth term of the sequence. So if sequences in which each pair of consecutive terms differ by a fixed amount, so you can think about that as linear, so you're adding or subtracting, we call that an arithmetic sequence. As opposed to a geometric sequence, so I just realized I spelled arithmetic wrong. Nope, I was okay, just kidding. Okay, a geometric sequence is going to have a fixed ratio. So you can think about that as times or divide. So let's just first of all see if we can recognize the pattern. So describe how this sequence term is going to be determined by find the next two terms and identify the geometric pattern, arithmetic or geometric. So in this case, to go from positive 3 to negative 1 and then negative 1 to negative 5, we are differing by subtracting 4 each time. So the next two numbers would be negative 13 and negative 17. The fact that we're subtracting means that this is arithmetic. And if you're not sure, you can always try doing like negative 1 minus 3, negative 5 minus 1 and see if that is the same. In this case, to get from 1/16 to 1/8 to 1/4 to 1/2, you may recognize that as timesing by 2. So the next numbers would be 1 and 2. So if we're multiplying, this is geometric. Okay, this next one, to get from 3 to 7, 7 to 12, doesn't look like we're multiplying by anything, but it does look like, in this case, we're adding adding 3, then we're adding 5, then you may notice we're adding 7 and 9. So the next term, we're going to add 11, and we get 39, and then we add 13, and we get 52. So while this is a pattern, this one is neither. This last one, 1, 2, 6, 24. You may be like, well, we're adding 1, then we're adding 4, but then we're adding 18, right? So then that doesn't really quite make sense. If you think about multiplying, we're timesing by 2, but then we times not by 2, we times by 3, and then by 4. So once again, this is a neither pattern. While there is a pattern, this is neither arithmetic or geometric, right? We times by 5. So if you wanted the next one, we would do 120 times 6 is 720. And then we'd multiply by 7 for the next one after that. And we'd get 5,040. Okay. So next, let's find the first 4 terms of the sequence, identified as arithmetic or geometric. So if we want to find the first 4 terms, you would first think about the first term is going to be a sub 1. So all we're doing is plugging 1 into the equation. So we get 4 plus 3 times 1 minus 1, which is 0, which gives us 4. And then for a sub 2, we're doing 4 plus 3 times 2 minus 1 equals 4 plus 3 times 1, which is going to be 7. A sub 3, you do the same thing, 4 plus 3 times 3 minus 1. So that's 2. 4 plus 3 times 2 is 10. And then a sub 4 is 4 plus 3 times 4 minus 1, which is 4 plus 3 times 3. So we end up with 4 plus 9, which is 13. These are the first 4 terms of the sequence, right? And then this one is arithmetic. You can see that it's adding 3, which makes sense because if you look at that equation, it looks like a linear equation. These next two are a little bit trickier because we call these recursive ones, recursive equations. So it means that we're going to have to base it off the previous term. So our first term is 1, but now we want to find the next 3 terms. So it told us that a sub 1 is 1. So if I wanted a sub 2, what I'm going to do for that is I'm going to do negative 3 to the 2 minus 1 all over a sub 2 minus 1 subtract 2. So we're really doing negative 3 to the first all over a sub 1 minus 2. And what you got to remember here is that a sub 1 is 1. So we're doing negative 3 to the first is negative 3 all over our a sub 1 is 1 minus 2. So we'd have negative 3 over negative 1, so we get a positive 3. Okay, to do the third term, a sub 3, we do negative 3, this time to the 3 minus 1. And then at the bottom, this a sub n minus 1 really means the term that comes before the third, so the second term, minus 2. So we'd have negative 3 to the second, all over 3 minus 2. So we have a positive 9 over 1, so we get 9. And then the fourth term, we do negative 3 to the fourth minus 1, all over a sub n minus 1 is going to be a sub 4 minus 1, so the third term, minus 2. So we'd have negative 3 to the third, all over 9 minus 2. So we get 27 over 7. Sorry, that's negative 27 over 27, so we'd leave it as negative 27 sevenths. These are our first terms. And in this case, it starts to appear like it's geometric, right? Times 3 times 3, but then it's not times 3 this next time. So in this case, this is going to be like neither arithmetic or geometric. Okay, let's do this next one. This next one gives us the first 2 terms. It tells us it's negative 1, and it tells us it's 5. But the notation for the third term is it says we're going to do 2 times a sub 3 minus 2 times 3 times a sub 3 minus 1. So we're going to do 2 times a sub 1, so the first term, so 2 terms before it, and then 3 times a sub 2, so just the term before it. So in this case, we're doing 2 times negative 1, and then 3 times 5. So 2 times negative 1 is negative 2. And then 3 times 5 is 15, so negative 2 times 15 gives me negative 30. And the next one with the fourth term, we're going to do 2 times a sub 4 minus 2 is the second term, so 2 terms before the fourth term. And then 3 a sub 4 minus 1 is going to be the third term, the one that comes before it. So we're going to do 2 times 5 times 3 times a negative 30. So we get 10 times negative 90, we get negative 900. Alrighty then. On this last one, so this is once again a neither pattern, neither arithmetic or geometric. On this last one, we're going to do a sub 1 equals 3 times 2 to the 1 minus 1, so we get 3 times 2 to the 0, which is 1, so we get 3. Our second term, same thing, 3 times 2 to the 2 minus 1, so we get 3 times 2 to the first, so we get 6. Our third term, 3 times 2 to the 3 minus 1, so 3 times 2 to the second, so we do 3 times 4 is 12. And the fourth term, 3 times 2 to the 4 minus 1 equals 3 times 2 to the third, which equals 3 times 8, which is 24. So these are our first 4 terms, and you may recognize that as geometric. And notice it looks like an exponential equation. Okay, so here are some formulas for you. In general, just so you know, these first 2 formulas are given to you on your equation sheet, and you have to just be able to recognize them as arithmetic and geometric. Recursive we don't use quite as often, but just so you're aware there, remember a sub n represents the nth term, and a sub 1 is the first term. D is going to be your common difference, R is going to be your ratio. So let's find some explicit formulas here. So in this case, we first want to identify as arithmetic or geometric. So that should be -2, -4. So -2, -4, -8, 16. It looks like here we're timesing by 2, so we're talking about something that's geometric. So our geometric equation is a sub n equals our first term, which is -2, times our ratio, which is a +2, and then to the n minus 1. Okay, on this next one, 3, 5, 7, 9, we're adding 2 every time, so this is arithmetic. So a sub n, our first term is 3, plus n minus 1, and then the difference, we're timesing by 2. This you can simplify and rewrite, so like a sub n equals 3 plus 2n minus 2, and this would be equivalent to a sub n equals 1 plus 2n, and those two equations are the same. But it's definitely a lot easier just to leave it in that first format. Okay, this next one, we got -5, 95, 195, and then 295. So this one's not maybe quite as obvious, but if you think about like, hey, -95 times -5 times what is 95? If you take 95 and divide it by -5, you get -19. But timesing that by 95, you get 1,805, so that's way too big. What actually is happening here is we're adding 100 every time. So once again, it's arithmetic. So you got a sub n equals -5 plus the difference, plus n minus 1 times our difference of 100. For the record, you can also do 100 times n minus 1. That works as well. Okay, last but not least here, I've got -1, 4/5, -16/5, 64, 125. Oh, that should have been 64 divided by 125, sorry. Once again, a little mistake there. So here you can kind of recognize that it's timesing by 4/5. But then how does it switch the negative sign? It's by a -4/5. So once again, it is geometric. So a sub n equals our -1 times -4/5 to the n minus 1. If you have a hard time recognizing those patterns, I would always try subtracting the two numbers and then dividing them and see which is the same. Okay, write an equation and find the specified term for each arithmetic sequence. So in this first case, our equation, if it's giving you a D, we know, it says these are all arithmetic. We have a sub n equals -25 plus n minus 1 times the -9. So if I want the 37th term, I'm going to do -25 plus 37 minus 1 times the -9. At that stage, so we've got our equation. I would just plug in your calculator, so like -25 plus, whether you want to do the parentheses 37 minus 1 or just do 36 times -9, we get -349. Okay, on this next one, the tricky part is it doesn't actually tell you the difference. But if you wanted to think for a minute, okay, a sub n equals my first term plus n minus 1 times the difference, an easy way to find the difference here would be to plug in your a sub 7 and your -31. So -31 equals 17 plus 7 minus 1 times the difference. If I subtract 17 from both sides, I get -31 minus 17 is -48 equals 6d, so your difference is a -6. So the equation then is just 17 plus n minus 1 times the -6. I definitely lied, -8 there, right? -48 divided by 6 is a -8, my bad. Okay, a sub n equals 17 plus n minus 1 times a -8. And then to find the 87th term, all we're going to do is plug in 87 for n. Oops, I forgot the minus 1. So 17 plus 87 minus 1, or an 86, times -8, we end up with -671. Okay, last but not least here, the hard part about this one is that we have the 3rd and the 10th term, right? So we could say, we want to find the difference, right? Kind of want to find the difference. You also want to find probably the first term here. So in this case, I would maybe just start by thinking about this difference. To get from the third to this 10th term, we're adding this difference 7 times, right? You add it once to get to the 4th, twice to get to the 5th, etc., until we get to the 7th. So I wanted to think about the starting point is negative 17.1. If I add the difference 7 times, I should get the result of the 10th. For the record, this is not the only way to do it. This is one way, though. So then we get the 7 times the difference. If I add 17.1 to both sides, I get is 1.4. So the difference is 0.2. In this case, I could go back and then, subtract 0.2 twice to get the first term is, so negative 17.1 minus 0.2 means negative 17.3 is the second term. Subtract it again, we get the first term as negative 17.5. At that stage, we could just say a sub n is equal to negative 17.5 plus n minus 1 times this difference of 0.2. So the 21st term is negative 17.5 plus 21 minus 1 times 0.2. Or the other option I would say at this stage is to, we get negative 13.5. The other option would be to think about starting still with that negative 17.5, but to say, hey, to get to the 21st term, we're adding this difference, 18 times. Or, start with the 10th term and add it 11. Okay, we're going to do this similar idea, but now we're going to do geometric ones. So this first one, write an equation, a sub n equals my first term times my ratio of 3 to the n minus 1. So I'm looking for the fourth term, 2 times 3 to the 4 minus 1 is the same as 2 times 3 to the third, and we get 54. Okay. On this one, the tricky part with this one, once again, is that we have the 7th. Well, I do have the first, I got to figure out what that ratio is. So 512 equals the first term of 64 times the ratio to the 7th minus 1. So I'm going to divide both sides by 64, and I get 8 equals your ratio to the power of 6. Take the 6th root of both sides, and while that is not a super nice number, the ratio here is the 6th root of 8. So our equation a sub n equals 64 times the 6th root of 8 to the n minus 1 is probably the easiest way to write that. And then to find the third term, we would simply do 64 times the 6th root of 8 to the 3 minus 1. And when you type that in, or when you do some math, that actually ends up being quite nice, because even though it's the 6th root, when you square it, we get the third root. And so the third root of 8 is just 2, so 64 times 2 is 128. Okay. This next one, I would probably use a similar approach to what we did before. So the 8th term is 6.25. The sixth term is 25 times your ratio. And in order to get from the 6th to the 8th term, we're going to do it twice, so the ratio squared. So 6.25 divided by 25 gives me 0.25 equals the ratio squared. So if I take the square root of both sides, the square root of 0.25 is 1/2 is your ratio. So in this case, if we want this 15th term, a couple different ways we could do it, but I think probably the easiest way to find the 15th term would be to start with the 8th, and then just say, okay, well, to get from the 8th, and then our ratio is 0.5, and to get from the 8th to the 15th term, we're multiplying that ratio 7 times, right? Because multiply it once to get to the 9th, twice to get to the 10th, and then 5 more, so 7 times, so 0.05 to the 7th. So 6.25 times 0.5 raised to the 7th gives us that the 15th term is 25 over 512, which is approximately 0.049. Okay. Last but not least, which term is 83 in the sequence? So first of all, let's look at the sequence and then we'll figure out the term. So in this case, we are adding 2 every time, so it's arithmetic. So a sub n equals 1 plus n minus 1 times 2. So if we want the 83rd term, in this case, we're solving for n. Subtract 1 from both sides, we get 82 equals 2 times n minus 1. Divide both sides by 2, we get 41 equals n minus 1. So n here would be the 42nd term. Okay, you're all set for